So real quick, here's just kind of the two affiliations I have right now. I'm actually the former chair of the Critical Minerals Committee at AAPG. Ashley Dowd has now taken on that role, and she'll be speaking to the group later this week. And so Critical Resources Consulting is just a private consulting company I have that does support for various projects, including at the exploration stage in the ground, and then all the way up to kind of government relations work around critical minerals. And then U.S. Critical Minerals is a private mineral exploration company that I co-founded, and we're involved in building out early stage prospects related to critical mineral supply chains, particularly for battery materials and for rare earths. So just kind of what's a basic definition of critical minerals, so we're all on the same page and we all kind of know what's going on with this emerging industry. So it's kind of the bullets for the definition based on the United States Geological Survey. So it's basically, it's essential to the economic and national security of the United States. It's a supply chain that's particularly vulnerable to disruption. And these are raw materials that are essentially unsubstitutable. So they serve an essential function in manufacturing. And you see the list of critical minerals there on the right. And also you can see our dependence on foreign countries to source this material. And one of the things that I want to point out about that list is you look at them, and most of those are actually elements, not minerals, right? So you're going to find a mineral, you're going to mine that mineral, and then you're going to extract out actually the elements or some compound that is really what you're after. And it's really elements that have these unique properties that we're trying to utilize for modern technology. And so the reason I make that point is it's really important to understand with critical mineral supply chains that there's kind of two components to it. There's what happens at the mining stage. So it's just the traditional, mining rock or extracting minerals out of the ground. In the case of like a lithium brine, right? You're extracting a brine-rich fluid to the surface and then getting out the materials that you want. But at that mining stage, you're very much talking about creating a run-of-mill or a run-of-mine mineral concentrate. And this would have been, what would have been used more traditionally for kind of traditional industrial low-tech markets. But for these emerging supply chains, what's really the most equally important, and in some cases more important, is having the advanced manufacturing capability to convert that run-of-mine concentrate into technology-ready material. And again, it's really the latter that is most critical in modern society. It's really the latter where most of the demand is. And it's also the latter which is the hardest to achieve sustainable, high quality supply chains of. And so for most projects in the Western Hemisphere, so most aspiring lithium companies, graphite companies, rare earth companies, they're really going to have to find a way to be vertically integrated for their operations to really be economically attractive to investors. So it's one thing to prove that you can mine a material, you know where to go get it, but it's another thing to be able to prove that you can make, again, technology ready material. So it's really talking about, massive scale mining, but at the end of the day, you're creating and trying to sell a pharmaceutical grade material to your customers. And so there's the huge component of consistency of quality that really matters to these emerging industries. And so just a quick reminder that, critical minerals, essentially are at the foundation of all modern technology. So it's not just about energy, but this is really, underlies, the essence of all modern day supply chains. And certainly COVID has kind of underscored the necessity to shore up these supply chains and regionalize these supply chains to the extent that's possible. And then just kind of making the point in the bottom right hand corner of this is when it comes to specifically like lithium ion batteries and kind of trying to coordinate the political will at the federal level to really understand the necessity of these supply chains. So, the politics of green energy and the energy transition is very much a real thing. But it's important to realize that lithium-ion batteries is the battery of choice for our military. So the typical soldier has 15 to 20 electronics when they're in the field, and most of those are powered by a lithium-ion battery. And so this is not just about, the future of energy security, but this very much involves national security. And because of that, it's a great opportunity to find political will on both sides of the aisle to work together. So there's kind of no wrong reason to develop critical mineral supply chains. Here's just a quick kind of example of going from the mining stage to the advanced material stage with natural flake graphite. So this is a material that I've worked a lot with over the last decade. And so talking about the just the run of mine concentrate stage. So this is an example from the Alabama graphite belt. So you're talking about mining a graphitic schist at the raw material stage. So the rock has about 2 to 4% graphite in the schist. And so you mine the material, you crush it, you float off the graphite. Graphite's hydrophobic, and you make a graphite concentrate. And that graphite concentrate, if you've done what you're supposed to do, you should end up with a concentrate that's somewhere in the mid-90s as far as the percent carbon purity. So graphite is one of the naturally occurring forms of carbon. And so 95% carbon would be considered a nice run-of-mill concentrate. So this would have been used again for the steel industry, for foundries, industrial lubricants, greases, all these kinds of things. And at that point, you've created a material that's, on average about $800 a ton selling price. However, that's not the material that's needed for emerging technologies. So graphite is the main component of the anode of a lithium-ion battery. But to make battery quality graphite, you have to purify the material. So now you have to take it from 95% carbon to a minimal of 99.95% carbon. And then you have to size it, shape it. And actually, in the case of for electric vehicles and lithium-ion battery anodes, there's actually a final coating process that happens at the end as well. But the main point I'm trying to make is, as you go from left to right on this graph, you've created the price of the material is gone up in by an order of magnitude. However, your capital cost is not. And at the end of the day, you've now created a material that is also much more in demand. So again, the vertical integration is an opportunity to capture value, but also capture the part of the market that is most exciting and most interesting. However, again, you're talking about developing essentially two simultaneous projects or even companies in parallel with one another. You're a mining company and then an advanced materials company. Just real quick, an example with spodumene. So again, very similar. You're talking about mining a hard rock. These are found in pegmatite systems. The spodumene is concentrated either through a gravity separation or through a flotation method, depending on the deposit. And again, you're talking about, at the end of the day, a material that's selling for north of $1,000 a ton. It's interesting that the price of lithium has actually been going up so much lately that my figure is out of date now. So actually, there's prices of spodumene concentrate now selling for closer to $1,000 to $2,000 a ton. But still making the same point that once you talk about making a battery quality lithium chemical, so in the case of spodumene, the most common conversion is to take that spodumene concentrate and convert it to a lithium hydroxide. And again, you're seeing an order of magnitude increase in the sell price, but also order of magnitude in difficulty in making that finished product. So one of the main underlying challenges with the clean energy transition is the fact that the clean energy transition requires orders of magnitude more mining than fossil fuels. And so we have to find a way to stomach the fact that we want to have green energy, but we have to be a mining intensive society. And so, but control over these supply chains certainly is going to determine both the economic strength and defense security of countries going forward. So this is certainly something that we cannot ignore, and it's not something that we can kind of hand off to others to take care of for us, because as we can see with what's just happened with COVID, even if we're relying upon our allies for trade, once you start to have these disruptions, there's just a lot of things that can go wrong. And so the ability to regionalize these supply chains offers great opportunities. But so looking at this graph on the left, this is from the World Bank, and notice that the first the three elements that are listed as kind of most critical, where we're going to see the most demand growth over the coming decades, those are all the main components of the lithium ion battery. So graphite on the anode side, lithium and cobalt on the cathode side. And so, it's taken all of human history to get to the point where we can produce 1 million tons of lithium carbonate equivalent per year. However, we've got to find a way for the market to double by 2030 if we're going to come even close to meeting some of the goals of the clean energy transition. And then, the challenge with this is most of the largest supporters of green energy and the clean energy transition are hesitant to embrace mining. And so, mining has earned a bad reputation over the years. And, one could certainly argue that that's been well deserved. However, there are opportunities to do things the right way. And so, again, the challenge is, how do we have our cake and eat it too, I suppose. So this is news that's been front and center. Actually, there was, I haven't got to see it yet, but I heard there was a CBS special over the weekend talking about the Thacker Pass project, in Nevada, where you've got a really, a high class deposit. There's a very professional team developing that project. If you look in the grand scheme of things of where to build a mine, in my opinion, it's a pretty good place to do so. It's particularly with the amount of lithium that's in the ground there. However, local ranchers, local environmentalists, local indigenous groups are hesitant to support the project. And so again, how do we build the mines that we need for this energy transition, but also embrace the fact that we have to do a lot more mining to do so. So the not in my backyard is a strong opinion that's held by many in the Western world, particularly in the United States. So nobody wants to be close to a mine, but in fact, the best opportunities to lower the carbon footprint, to lower the overall environmental footprint of these supply chains, is to in fact regionalize them. Not only because in the United States we have stronger environmental policies, but it's just the basic moving these raw materials around. So like in the case of most hard rock lithium right now, it's mined in Australia as a spodumene concentrate and then shipped to China and Southeast Asia to be converted into lithium chemicals, and then from there shipped all around the world. So to the extent that we can mine the material, process it, and then get it into a battery all within a couple 100 miles of itself, really creates a huge opportunity. Also, being able to partner the processing components of this industry with a greener grid, even if it's putting powering an operation through a gas-powered grid comparing to a coal-powered grid. In fact, that has a huge impact on the overall carbon footprint of the final product. And again, what's driving this? So electric vehicles is really the main driving force behind a lot of the surge in lithium, graphite, cobalt, nickel. And so there's a lot of different graphs. I'm not trying to say that this is the graph I think is the best, but what I'm trying to point out is to see where we are on this graph, right? And so for somebody that's been involved with the battery materials industry for going on a decade now, trying to develop domestic supply chains and seeing more so the challenges with doing so in the last 10 years, you could see that we were still really early to the market compared to where we're going. And so certainly, post-COVID, and as as there's starting to be a lot more certainty in the US market as far as the adoption of electric vehicles and clean energy technology, I think it's safe to say that this wave of excitement that we're seeing now is very much the kind of the real wave that a lot of us in the industry have been waiting for. And so, we're still very early on in the adoption curve of this technology. Yet, in order to come close to meeting, the goals of this adoption curve, it's really the raw material side and the battery chemical side that's going to be the bottlenecks to allow this this kind of vision to come a reality. So just obviously the success that Tesla has had in this industry this has certainly been the poster child of success, particularly in the United States. And some of the raw material companies that have been associated with Tesla, that have had some sort of side agreements with Tesla, they've seen great success as far as their stock price, but also being able to get the funding in place to take these projects from the exploration, discovery stage, feasibility stage, to actually getting them fully funded into production. And so there's been a lot of work over the last decade in the United States and North America and South America, and all around the world, trying to figure out, well, where are these new supplies going to come online? And most of the funding has been restricted to those early stages. And so there's been a lot of projects where they proved out a resource, they proved out the economics of the project, maybe they even got it to the engineering and feasibility stages. But all these projects have been kind of sitting there waiting to get the funding necessary to get into full production. And so that's finally something that we're starting to see now that's happening over the last 6, 12, 18 months, that there is starting to be a lot more momentum. Now, instead of seeing companies raise, $3 million, $5 million, $10 million to develop their projects at those early stages, now we're starting to see companies raise $10 million, $30 million, $100 million, and north of that to really bring these projects online. So things are happening very fast in the industry. There's also a lot of consolidation happening in the industry, where some of these mid to late stage projects are now being bought out by the majors. And so certainly, again, all this was really accelerated by the success that Tesla has had over the last year. Tesla's Battery Day just over a year ago really kind of jump-started things. The biggest thing on the lithium side was the fact that they announced that they're going to build a lithium hydroxide facility in Texas. And so this is really the first major one of scale. There's been a small one in North Carolina to date, but this is the first kind of massive lithium hydroxide facility to be built in the United States. And as a result of that, you saw a company called Piedmont Lithium, which is developing a hard rock asset in Western North Carolina. They've got kind of the furthest along hard rock project in the United States and really in Canada. Well, it was no coincidence that when the lithium hydroxide facility got announced by Tesla, well, hard rock lithium is the best feedstock traditionally to make lithium hydroxide. And so the morning after the lithium hydroxide announcement, there was an announcement that Piedmont Lithium had in fact signed an offtake agreement to supply Tesla. And so you saw a huge rise in their share price, and then that kind of spread across the space to where really ever since this kind of week last year in September, you've seen continued momentum across the battery material space, because all of a sudden, for the first time, investors in the industry was kind of able to see finally a success in the arena of kind of aspiring and developing new projects. And so this was really the first one where all of a sudden it was a huge win for investors. And then essentially the investor market was hungry to find what are going to be the additional projects that come online to support this growing industry. And so again, the wave of excitement that's happened over the last 12 months, not only from retail investors, but from institutional investors to put money into this industry, it's been a game changer over the last 12 months. So again, a lot of excitement, things are moving fast. There's a lot of consolidation, and projects are now starting to get the funding they need. Although one could argue it's a little bit late to meet some of the near term and medium term supply chain bottleneck potential issues that we're going to face. And so in addition to Tesla, I think the other thing now that we're seeing across the space is it's not just Tesla, right? So you're seeing major announcements from Mercedes to other aspiring battery material and recycling companies to even Ford making a major announcement now. And the thing is too, is this is now translating to jobs on the ground across the United States. And one of the things I'm really excited about is it's areas of the United States that are traditionally kind of conservative, coal focused states. So, as somebody that's been working in the battery materials space and been working in a lot of these states that are traditionally very proud of the fact that they contribute to the coal industry, there's been a lot of hesitancy with them to embrace this industry. And I think it's a fair assessment to say 10 years ago, green energy meant probably a job on the West Coast for somebody. And so the fact that folks can see that as this industry emerges, it means a job for somebody in Kentucky. It means for a job for somebody in Alabama or Tennessee. And this can be, in the case of Alabama, there's still the opportunity to remove carbon from the ground for this technology. It's just instead of instead of coal, it's in the form of graphite. And so there's opportunities for mining, there's opportunities for manufacturing. And again, to the extent that people all across the country and from all political walks of life can see the fact that, hey, this is an opportunity to create jobs, to create wealth, to create a better technology, to create a better environment. Again, it doesn't really matter what's the talking point that gets you excited about what's happening. It's just, it's this underlying theme that there is kind of something for everybody in this industry. But again, the challenge is making sure that the investments are made in a timely fashion to bring about the supply chain. And so the problem right now is if you look across the various stages of the supply chain, so starting all the way upstream on the extraction side or the raw material and mining side, going all the way to the downstream on the final product side, so talking about lithium ion batteries, electric vehicles, it's the downstream where all the investments have been made. Okay, so over $300 billion committed to building out electric vehicle technology and large manufacturing across the world. Okay, there's been the cell manufacturing investments have been made as well. However, there's been a gap in the component stage, the advanced material stage, and then the extraction stage. So the vital pieces to make the cells function and the electric vehicles function, those investments have been lacking. And so again, how do we have this clean energy transition if we haven't been making the necessary investments in a timely way that's going to allow this industry to grow how it needs to grow? And this information is from Benchmark Mineral Intelligence. For those of you who don't know this group, they're out of London. They do world-class work on the lithium-ion battery supply chain, starting at the raw material side and going all the way through the technology side. So this is more data from them. And again, these guys are world-class. They do a lot of really good events. So I encourage you guys to follow this group. But so looking at the three stages of the supply chain where the investments are lacking the most, the largest concern about that is that China is continuing to kind of not only right now exerts kind of almost complete control over the supply chain, but they also, if you also looked at a chart showing where the investments are being made in the supply chain, it would almost look identical to this. So not only do they currently control these supply chains, but they continue to outpace the Western world in investments to basically to ensure their dominance. But just really quick, so looking at the mining stage, processing stage, and then taking those battery chemicals and making the important components of the battery, the cathode, which is the positive side of the battery, and the anode, which is the negative side. You can see that the European Union and the United States are virtually absent from the supply chain. Now there is a kind of a frantic move right now to fix this. I would say the Europeans are a little bit ahead of the United States on this. But one of the things I want to point out is the fact that it's really important to not only control access to the raw materials, so the mining components of these supply chains, but also on the processing side. And basically, you really need to be able to have both the mining and the processing if you're going to have control over your own destiny in the supply chain. And I want to point out a couple things real fast. So if you look at the lithium on the mining stage, and notice that the Chinese do not do a significant amount of mining within their borders. They actually are developing some new projects right now, and they are invested in projects outside of China. However, most of their ventures are not happening within their borders. However, if you look at the refining stage, you can see that they're able to, even without the mining, they're able to control almost 60% of the supply chain, because they do control that chemical conversion process. And then you can see that this is a reoccurring theme for a lot of these raw materials, and it's certainly a famous kind of situation when it comes to rare earths that they've historically controlled this industry. So again, it's important to be able to have access to the raw materials, but as a nation, it's equally important that we're also investing in the downstream conversion capability. And then I kind of already made this point, but just trying to, as far as things that our country fights about, it's hard for us to get along. But as far as the critical mineral challenge and opportunity, it does seem to be one of the things that there is overwhelming bipartisan support for. So President Trump had put a critical mineral executive order in place under his presidency on the tail end of the U.S. Geological Survey updating the critical minerals report. But very quickly, with President Biden took over, he did his own critical mineral executive order. And one of the things that was kind of interesting about the way that he signed his critical mineral executive order is he specifically tied it also to medical supplies, supercapacitors, and to battery and rare earths. So it was very much kind of this is all very important. These supply chains are crucial, and they all need to be addressed with the same level of importance. So some of the different contacts I have in DC thought that this was particularly relevant, that it wasn't a standalone executive order, that it was in fact grouped together with particularly the medical supply chains, which are so important and front and center right now. So these are just a couple of the talking points that I've already hopefully addressed to some extent, but again, this really covers a wide range of things that our country needs. So we're talking energy, defense security, economic and trade security, and again, to the extent that we can really be vertically integrated, that's where most of the value is going to be created. But the whole point of the clean energy transition is to have a greener, cleaner, better environment. And so it's extremely important that at the mining stage, at the processing stage, at the battery manufacturing stage, we're doing everything we can to make sure that that environmental footprint is minimized. And as the grid in general gets greener, in the case of you owning an electric vehicle and wanting to charge that electric vehicle on a clean grid, as that becomes better and better, the remnant CO2 footprint, the remnant environmental footprint in that technology is largely going to be the process of getting those raw materials all out of the ground, converting those raw materials into a battery grade material, and then making the cathodes, the anodes, and the battery themselves. And so again, to the extent that that process can be regionalized, can be put on a cleaner grid, can be done so under clean mining regulations or strict mining regulations, it really offers amazing opportunities to make sure that this is done right, and that we kind of recreate the vision that we all have in our minds of what the mining industry looks like. And again, certainly a significant long-term opportunity for job and wealth creation. So estimated $24 trillion in wealth over the next 2 decades from the EV and battery industry. Uh, this is just kind of highlighting the opportunity in the southeastern United States. So this is an area that I work a lot out of. And again, just kind of making that point that, you know, the heart of coal country is on the verge of becoming the backbone for the future of clean energy. So, and it's not just, so it's the raw materials. So again, you got a hard rock lithium deposit in western North Carolina. You've got the Smackover Formation in southwest Arkansas being developed as a lithium brine. You've got a graphite belt in Alabama. You've got heavy mineral sands mining along the Georgia and Florida coast. That has zircon, titanium, but also monazite, which is a rare earth mineral. So we've got rare earth mining in the southeast as well. And then the kind of important manufacturing components, big battery manufacturers being built. I do not have the latest Ford announcement on this map. So again, you know, you wait 2 to 3 weeks and you know, this data is already out of date right now because it's happening so fast. But again, also important is the fact that the Southeast is kind of the center for aerospace and defense manufacturing as well. With that, kind of all roads point to NASA. But again, you know, aerospace defense technology very much dependent on these critical minerals, particularly things like rare earths. And so this is, you know, again, a great opportunity to regionalize these supply chains for our country. For the sake of time, I'm going to kind of skip over this, but it's basically, this is a really important figure, but trying to just point out the fact that building a mine from the discovery stage to actually operation is a long, lengthy, and complicated process. And then once you add the second component of not only do you have to build out a mine, you have to build out an advanced material technology company. It's a difficult process. And like I said, building a mine is hard enough. It takes a lot of time. It takes a lot of money on average. But when you're talking about producing a battery quality raw material, well, a lot of times the qualification process takes 2 to 3 years to get your new battery graphite or your new battery quality lithium into a lithium ion battery. And so not only do you have to prove that you've got something in the ground, then you've got to prove it at the laboratory stage that, hey, we can make this, you know, we can take the graphite from Alabama and we can make a battery quality coated spherical graphite with it. Well, then you've got to prove that you can do it at scale and that you can consistently produce your material at scale. And then you've got to have a 2-year courtship with your potential customer, proving to them that you can do this at scale, proving to them you can meet the timelines needed. And it's very much often ends in a chicken or the egg situation where your customer is kind of ready to commit to you, but they want to know when you're going to be in full scale production. And on the other side of that, your customers, or I'm sorry, your investors are interested in investing, but they want to know where the contracts are with your customers. And again, those customers aren't going to sign those contracts until you kind of proven that you can do something at scale. And it's really hard to do something at scale if you're not properly funded. You know, building an on-site demonstration plant can cost tens of millions of dollars to do, and that doesn't necessarily, you know, is going to be generating profit. It's more so demonstrating your ability to operate at a high level. And so it's kind of a necessary stage to get you over that hump into production, to get those commercial contracts. But it's also, and many times, a hard sell for investors because it's, you know, you're increasing the level of financial commitment to the project, yet there's still quite a bit of technical risk involved. So this is just kind of an overview slide, pulling things together. Basically, you know, there's a lot of the culture around mining is still something very much in the United States that needs to change and kind of evolve, but the industry very much has to work with kind of society and with local stakeholders to build this new level of trust, to kind of you know, reimagine what mining does look like, and because it's absolutely a necessary part of the energy future. And so really look for opportunities to come together politically to make sure things that are done right at kind of every step of the process as far as minimizing the environmental footprint, trying to regionalize supply chains to the extent possible. And I think whereas capital has been on the sidelines over the last couple of years in the United States, waiting for the certainty in the market, I do think that certainty is coming to light right now. And so the thing, I guess, is from being somebody that's been in the industry for a while, you know, the main concern I have now is that just making sure that the right money goes to the right projects, because we're kind of in that situation right now where it's kind of like, you know, the realization like, oh no, we should have done this 5 years ago. And so, you know, we want to be careful that there's just not silly money thrown at silly projects. And so that, I think that'll be one of the biggest challenges over the next couple of years, is just making sure that the right projects are funded sufficiently, and then making sure the projects that really don't stand a chance to be commercially successful, that those are kind of, that the market is able to separate those and make kind of good, wise investments, and build out projects in places that it makes sense to do so. So with that, appreciate the opportunity to speak. Sorry, that was a bit of a ramble, and but it's, again, just meant to kind of be an overview. Happy to answer any specific questions that anybody might have, and I'll make my talk available if anybody would like to have access to that. But thank you for the opportunity to talk.